In our previous video, we talked about the concept of a function, how it works. We also discussed about the derivation and its solving principles. So in this lesson today, we are going to consider function of a function, otherwise known as a composite function. Now, this concept is very simple. When we say function of a function in calculus, we mean applying one function first, then applying another function to the result. Applying one function first, applying another function to the result. Now let me give you a real life concept how function of a function works, so you don't forget about this. Dr. Hosfor is the lecturer who conducted the physics practical last week in Rivers State University. After the practical was conducted, I left the lab without my phone. Then thereafter, I called Dr. Hosfor and ascertained that my phone was safe in the lab. So yesterday, I told my friend who is bearing Chika, "Hello, Chika, go to the physics lab. Dr. Hosfor will give you my phone." Chika replied, "All right." Then Chika was not chance to execute my command. That is, he did not go. Chika called his friend who is bearing Emmanuel. "Hello, Emmanuel, go to the physics lab and get my phone." Then Emmanuel was not also chance to go and get my phone. Emmanuel called his friend who is bearing Blessing. "Hello, Blessing, go to the physics lab and get my phone." Then Blessing finally went to the lab and my phone got to me. Now let's pause at this point. Do I know who is bearing Emmanuel? No. Do I know who is bearing Blessing? No. All I knew is that I contacted Chika and my phone got to me. That is exactly how function of a function works in mathematics. The output of one person becomes the output of another person until the final result is obtained or reaches us. That is the reason when solving a problem in calculus, a function will be given to you. Now remember that function comprises of only two letters. So a function will be given to you such as y is equal to 4x squared plus 3x. This will be given to you where we have y and x only. Then when the solving begins, you start seeing letters such as u and v. So now where is the u and v coming from? It is coming from Blessing and Emmanuel, from this scenario that was given to you. That is how simple it is, and that is how it works. So we are going to consider three basic rules of differentiation, or three functions of a function. And the first is chain rule, second is product rule, and the third is quotient rule. Most students usually mix them up when the question is given to them under composite function or function of a function. But in this video, I'm going to show you how to identify them, simple trick, how to remember any of these rules when a question is given to you. Now let us consider the first differentiation rule on the board, which is called chain rule. Understand this concept. When we say chain rule, we are talking about a function inside another function. So the simple trick about chain rule is that a function is written inside another function. So examples of chain rule are y is equal to bracket open 3x minus 4 raised to the power of 5. A function is written inside another function. Another example is y is equal to e raised to the power of 2x. Another example, y is equal to sine 3x. All these are examples of chain rule. Now, if you are considering these three examples on the board, we observe that in each of the function given or equation given, there are just variables x and y. That means y is a function of x. So we have y and x in the first function, y and x in the second function, y and x in the third function. So because y is a function of x, we can say that y is a function of x. So the derivation of y with respect to x could be given as dy over dx. Or if I don't want to use the term dy over dx, I'll write f at x. F at x or f prime x. So since y is a function of x, then the general formula for chain rule for derivation becomes dy over dx will equal to dy over du times du over dx. So this is the general formula for chain rule. Dy over dx is equal to dy over du times du over dx. Now, having known this about chain rule, let us consider these three examples on the board. Now, the first function is that y is equal to bracket open 3x plus 4 bracket close raised to the power of 5. Now, when it comes to calculation or solving under chain rule, take note of this concept. This is very important. Y is equal to a function of x raised to the power of 5. Now, the observation is that this bracket belongs to the categories of x. That is to say, this is a group of x. Everything inside the bracket is called the group of x. When it comes to chain rule, always ensure that all the group of x are represented using letter U. Letter U. So this bracket will become U. So if you are considering the second function on the board, this is the group of x, 2x. So that means it will become U. Again, considering example number 3, or in the third equation, this is group of x, and this will also become U. So if you are required to represent everybody here by U, it will simply gives y is equal to, this is group of x, it will become U raised to the power of 5. The concept is that we must represent the group of x or the group of the independent variable by letter U. Take note of that. And also to this, so this becomes y is equal to group of x is this. So that will become e raised to the power of u. Also, let's consider the third one. This will become y is equal to sine u. Now, having known this, we can solve these three examples, 1, 2, and 3, using the principles of chain rule. Now, the first is, number 1, y is equal to, in bracket, 3x minus 4 raised to the power of 5. Now, the question is, find the derivation of y with respect to x, dy over dx. Solution. Now, when a question is given to you under chain rule, the first thing we have to obtain is to represent the group of x by the letter u. So that means if I'm rewriting this equation, y will equal to u raised to the power of 5. U raised to the power of 5. So what is u? What is the meaning of u on the board? U is representing a particular set of numbers or quantities. That is, u is equal to 3x minus 4. Having known this, we can determine the derivation of y with respect to x. But before we can get dy over dx, we have to consider this derivation and this derivation respectively. So the first is that we have dy over du from the formula. What is the meaning of dy over du? Dy over du means the derivation of y with respect to u. That is to say, we are going to find the derivation of a function with letter y and u only. Now on the board, any equation that comprises of letter y and u, its derivation becomes dy over du. So right here we have y and u. That means the derivation of this will become dy over du. Let us also recall that if y is a function of x, ax raised to the power of n, then the derivation of y with respect to x will be given as dy over dx will equal to, multiply this by this, and then subtract 1 from the power, n minus 1. So that gives dy over du. From here, dy over du becomes 5 times the coefficient of u on the board, and the coefficient of u is 1. So that becomes 5 times 1, 5 times 1, then u raised to the power of 5 minus 1. That gives dy over du will equal to 5 times 1 is 5, then u raised to the power of 4. U raised to the power of 4. U raised to the power of 4. So we have determined dy over du from the formula. And now we are left with du over dx. Now to find the derivation of u with respect to x from the formula, we are going to consider another set of equations on the board that comprises of only 2 letters, u and x. Du over dx is equal to, applying this derivation formula into this equation, we have, and note that the power to this is 1. So it will be 1 times 3, 1 times 3, or 1 times 3, then x raised to the power of 1 minus 1 minus. Now take note that the derivation of a constant term is always equal to 0. So minus 0. So du over dx will give 1 times 3 is 3, x raised to the power of 0. Anything raised to the power of 0 is 1. So 1 times 3 is 3. So dy over dx will equal to dy over du. And dy over du is 5u raised to the power of 4. 5u raised to the power of 4 times du over dx. And du over dx is equal to 3. So we have 3. So dy over dx will give 5 times 3 is 15. U raised to the power of 4. Now this is not the final result. Remember, the question was given to us in the terms of y and x respectively. Y and x. So your final result must be kept in the term of y and x also. That means since u was given as 3x minus 4, we are going to substitute that into this. So if you put 3x minus 4 in place of u, we are going to obtain 15 in bracket 3x minus 4 all raised to the power of 4. So this becomes the final result from the first function on the board. That is so simple. Let's consider the next function, which is y is equal to e raised to the power of 2x. The second function on the board is y is equal to e raised to the power of 2x. Y is equal to e raised to the power of 2x. The first thing we have to obtain is to ensure that the group of x or the x variables has been converted to letter u. So this is 2x from the x family or from the independent families. So we are going to change this into letter U. So if we change it into letter U, y will equal to e raised power of u. So y is equal to e raised power of u. Now how do we define u? U is 2x. U becomes 2x. So at this juncture, we can apply the general formula for chain rule, where dy over dx is equal to dy over du times du over dx. That is very simple. Now the question is, what is meant by the term dy over du? So if you are considering this question on the board, this is y, this is u. This is u, this is x. So dy over du is the derivation of the function that has only y and u in its equation. So that is this. Therefore, we have that dy over du will equal to, or it will give, e raised power of u. The derivation of e raised power of u is equal to e raised power of u. So we are done with this, dy over du. The next is du over dx. So we are going to consider that function or that equation that comprises of only u and x. So that is this equation u and x. So the derivation of this, that is du over dx, will equal to, if you apply the principles of derivation, this into it, it will give me, remember, we have 1 as the power of this variable. So that is 1 times 2 is equal to 2. 1 minus 1 will give 0. And any quantity raised power of 0 is 1. So that becomes 2. And we are done with dy over du as this. Then du over dx as this. Now the question is, what is dy over dx? Dy over dx, dy over dx will equal to dy over du, which is e raised power of u times du over dx, which is 2. So dy over dx, is equal to 2e raised power of u. But this is not the final result. Let's substitute back. U is equal to 2x. So if I substitute, I'm going to have dy over dx is equal to 2e raised power of 2x, which becomes the final result. Now let us consider the last example on the board, where y is equal to sine 3x. Y equal to sine 3x, the first thing we have to do, solution, y equals sine 3x, and we said that the first approach is to consider the group of x or the family of x in this chain rule. Provided this chain rule, the family of x should be equated to u, or should be made u. So if I do that, y will equal to sine u, just as this, sine u. Again, if y is sine u, then that means u is equal to 3x. dy over dx is always dy over du times du over dx. And dy over du, we are going to consider that function or that set of equations comprises of only 2 letters, y and u. And that is this, y and u. So the derivation of this function becomes dy over du. So how do we differentiate this? This is a trigonometrical function. In trigonometry, in calculus or differentiation, the derivation of sine u becomes cos u. Take note of that. So we have cos u. Now next is du over dx. Du over dx. Du over dx, we are going to consider that function that has only letter u and letter x. So that is u and x. So to find the derivation of this, that will give 3. Applying this derivation formula or principles, we have 3. So dy over dx now, dy over dx is dy over du times du over dx. That means it will give me cos u times 3, which is 3 cos u. And this is not the final result. What is the next approach is to substitute, isn't it? So what are we substituting? Remember we said let u represent 3x. So that means it will give me 3 cos 3x, which is the final result. If this video was helpful to you, click on the like button and also reshare this to your friends or to your social media handles. Also, remember to subscribe if you have not subscribed and watch out for our next video. In our next video, we are going to consider how to solve another basic rule of differentiation, which is the product rule, and how to identify them if a question is given to you. Thank you.